the biggest challenges of studying water is tracking how it moves through a system. Take a river, for example. How do you know how much of it came from surface sources like snowmelt or rain, and how much of it comes from groundwater? That is where radon comes into play.
So radon is a naturally occurring radioactive gas. But the neat thing about radon is it's nearly ubiquitous. We're gonna find it almost anywhere we have any kind of rocks or minerals or soils. And so we can use that in an aquifer system where we have the groundwater that's fully saturating all those tiny pore spaces. Those are going to be accumulating radon as the water moves through the groundwater system.
And we're able to use that as a natural tracer to understand how much groundwater is feeding to surface waters. We have a stream monitoring network in Scott River. We ideally want to go to the same site each time throughout the year so that we're very consistent in the location.
Do you want me to talk or just do it? All right, so I'm gonna take my 60 milliliter syringe and I'm going to do a triple rinse. And then I'm going to dispense until I get exactly 60 milliliters.
Then I'm going to take my Tedlar bag. I'm going to connect the syringe via the three-way valve to the Tedlar bag, open the valve on the Tedlar bag, and slowly inject the sample.
And that's our sample.
Once all the samples are collected, they are sent to the lab where Ben works.
This is the reality of lab work right here. You spend like 10% of your time getting gloves on. When the samples come to the lab, I will measure the temperature, the weight of the sample, and I will transfer 70 cc's of nitrogen gas to the Tedlar bag, and I will shake the bag for approximately 2 minutes. After that, I will extract the gas from the Tedlar bag to a Lucas cell, which holds the gas. I will put it into the machine behind me called the alpha scintillator.
The alpha scintillator.
Which will detect the decay of a radon atom.
So scintillating. They then chart the levels of radon over the course of the year and look for patterns.
Generally, we expect there to be a lower radon signature during winter when there's a lot more surface water flows in Scott River. And then we expect that in maybe June, July, the surface water flows go down, but then groundwater starts to flow into the river and provide a higher ratio of the water flows.
Radon is one of many tools that helps us understand how groundwater contributes to the Scott River at different seasons and in different locations. The more our understanding grows, the better we're able to manage our shared water resources. This is usually where I make some sort of water joke, but today I've run dry.